Hi and welcome back. The Arduino, even though it can interact with its environment, can't do anything at all without access to sensors and all kinds of components. And unlike most computers you are used to, it cannot tell the time. Although knowing the time is not needed in many applications, and indeed, we have not really needed it up to now, sooner or later you will come across a project where knowing the time is a requirement. It is true that the Arduino has a built-in sense for time. It knows how much time has passed since it started executing a program. It can use the millis function to get a time that represents this time in milliseconds. A similar function is micros, and it does the same thing as millis, except that it reports the elapsed time in microseconds instead of milliseconds. There are also the time-related functions delay and delay microseconds, which add a delay in your program, the first in milliseconds and the second in microseconds. Still, your sketch cannot ask the Arduino for the time. You could use an internet time server and poll it occasionally for the time, but this method requires internet connectivity, a dependency that may be an overkill for some projects. A real-time clock breakout board is a PCB that contains a timekeeping integrated circuit. It's like the watch you wear on your wrist. You glance at it to get the time. The Arduino will be able to ask the real-time clock for the time too. A simple application for a real-time clock is for time-stamping log entries recorded on an SD card. We'll look at this problem in this lecture. You can also consider applications where certain events must be scheduled, like turning an illuminated sign on and off, or taking sensor readings at predetermined times. In this demo, I'll show you how to use a typical real-time clock with your Arduino. I will be using the DFRobot TS1307 RTC breakout, which I purchased on eBay for around $4. This device, like many others, is based on the popular DS1307 clock IC, and it can do anything you would expect a good clock can do. It counts seconds, minutes, hours, days, years, goes up to 2100 and compensates for leap years. It also consumes very little power, 500 nanoamps, which when using the onboard battery gives the device life of around 5 years. So in this demo I'm going to show you how to connect the real-time clock breakout and set the time on it and then retrieve it. So for that I'm going to use this breakout board. This particular one is called TinyRTC version 1.1. I'll show you the website from where you can get the libraries and other information like schematics for this particular board. On the PCB, this is the chip that actually implements the real-time clock. This is a DS1307 real-time clock integrated circuit, which is very popular. This second IC here is an EPROM, so it implements or it provides about 32 kilobytes of memory that you can use for your projects, read-only memory that is. You can use it to extend your sketches. This chip. I'm not going to show you how to use this yet. I'm going to do another lecture for EPROMs specifically. The PCB also has a thermometer on it, which again I'm going to show you how to use that in another lecture. So the PCB also has a socket where I can put in a battery. So with this battery, when the PCB is not plugged into your Arduino and taking mains power, you can use battery power to retain the time. So a couple of things before I plug it in is that the PCB communicates with the Arduino using the IC2 interface, single data wire interface. So I have soldered the header onto this row of pins, and the pins that I'll be using are the serial clock SCL pin, then there's the data pin, and then there are two power pins, ground and 5 volts. So I've already done the wiring on my mini breadboard, so I'm just going to plug it in. I'm just careful so that this row here goes to the ground pin, then I've got 5 volts, then I've got the SDA pin, which is the data wire, and then the clock, the serial clock pin is the yellow wire. So on the Arduino Uno specifically, the serial clock for the IC2 bus goes to analog pin 5. So A5 is marked on my Arduino Uno board. And then the data pin, the orange wire, goes to the A4, so analog pin 4. This is specifically for the Arduino Uno. Other boards have got other pinouts for the IC2 interface. I'm going to show you those in a minute. And power. That's all I need to do for now. Let's upload the sketch. We'll plug it in first and upload the sketch, make sure it works, and then have a look through the sketch. Whoops, need to select the appropriate serial port. Yep, make that USB. Right, monitor. Alright, so you can see that because I had removed the battery, the clock initially, I'll stop the auto scroll here. The clock initially had this time as default. Once the board was reset, it was set to this time. So then the rest of the sketch just does some calculations, so days since the 1st of January 1970, and then it just adds some days and seconds and calculates a new time. Let's have a look at how it works. So in this sample sketch, we first need to include the wire library, which is a library that allows us to use the IC2 interface. Well, in this sketch, it is the library that uses that interface, not our sketch directly, but nevertheless, we need to include it first before we include the RTC library. I'm going to show you where to get that from in a minute. Next, we create an RTC object, so it's going to be a reference called RTC of kind RTC underscore DS1307. So it's a library or an object specifically for the integrated circuit we use for real time. In the setup function, we start a serial port to use with a monitor, start the IC2 interface bus, and the real-time clock. Next thing is to check for initialization. If RTC is not running, which happened after I removed the battery and the clock was reset, so this returned false, therefore it wasn't running, it was reversed with the exclamation mark, then we got into this block. So here we initialized the clock using the adjust function. We use the date time function, which comes with the Arduino IDE. It's a C function, and we just created a date object. I just said 2014, February the 16th, and the time, hours, minutes, and seconds. So this way you can reset the real-time clock to whatever time you like. Another way to do this would be to, instead of manually having to set the time in your sketch itself, is to use this way of initialization. So this is going to grab the date from the compiler. So this is a compiler instruction. This is replaced by the actual date at compilation time. So when you actually hit the upload button in the background, the sketch gets compiled and then uploaded. So at the compile stage, this syntax will replace this with the actual date on your computer, and the same thing happens with the time. So I could just as easily have done something like this, and then every time that I upload the sketch to the Arduino, the Arduino will, or the real-time clock will be reset with the actual time on your computer. Right, so it's your choice in any case. Once it's done, real-time clock is set. So we go into the loop function and we grab the time. All we do is to make a now call. So we use a now function as part of the RTC object. We grab the time out of it and we store it in the now variable, which is of type date time. We can extract each of the components of the date time object by just calling the appropriate function. So if we call .year, that's going to obviously return the year. With the print function, we pass the decimal modifier or parameter to ensure that what we get printed into the monitor is a decimal representation of the year. We do the same thing with month, day, hour, minute, and second, and print out a new line at the end. We can also do a few calculations. So for example, here we are grabbing, we're saying now and then using the Unix time function to grab the Unix representation of time, essentially seconds. So it gives us the time in seconds since the 1st of January 1970. And then we want to grab the number of seconds between now and the date back then. So we're just going to replace that, the number of days. So we're going to divide the number of seconds by 86,400, which is the number of seconds in a day, and that gives us the number of days since this day. For Unix, the start of time is the 1st of January 1970. Another calculation happens down here where we just add 7 days and 30 seconds. So it shows you how easy it is to do time calculations in your sketches. That's about it. This thing will repeat every 3000 milliseconds, which is every 3 seconds. Now, a couple of other things to show you. Okay, first, for the particular real-time clock that I'm using, the Tiny RTC, it's version 1.1. This is the website for the manufacturer. You can see it's a pretty cheap board. There's some nice resources here. So you can see that some of the nice features of this board is the interface. So it's just a single data wire. You can keep time in AM, PM, and 24-hour format. It compensates for leap years. It will go up to 2100 with accurate timekeeping. The battery can essentially last for at least 5 years. It draws very little power. And it gives us some other nice things to have. So there are 56 bytes of non-volatile memory, so memory that will persist after you remove power, where you can store things like serial numbers or passwords, things that you want your project to remember. Plus about 4 kilobytes of EEPROM. And as an additional bonus, you get a temperature sensor. That's another I2 interface type of device. At the bottom of the documents section, what you will need to download if you use this particular board is the library. And you can grab diagrams and schematics as well. Everything is concentrated in the same zip file you can download. The library specifically, so I'm in the libraries directory of my Arduino IDE, and this is the real-time library for my device that I'm using in here. All right, one last thing is the wire library. So I mentioned earlier that the Arduino implements this communications bus, serial communication bus that lots of devices can share on the same data and clock pin. And the only thing to be careful about is the pinouts. So different boards have different pinouts for this communications bus. So for the UNO, or if you're using the Ethernet Shield, those pinouts are analog 4 for SDA, the data wire, and SCO is the A5 pin, so analog 5. The Mega, Leonardo, and Duo have got different pinouts, so be careful to adjust the sketch to the board that you have. I'm going to have a lecture specifically dedicated to the I2 interface. It's quite a large topic to discuss.